Welcome to solverfy.
To find the nuclear density of the hydrogen atom, we find the density of a single proton. And hence we first need to calculate the volume of a proton. The volume of a proton V is equal to 4/3 pi r cubed, where r is the radius of a single proton. So this is 4/3 times pi, and the radius of a proton we can get from a table to be 0.85 times 10 to the minus 15 meters all cubed, and hence we get a volume of 2.57 times 10 to the minus 45 cubic meters. And therefore we can calculate the nuclear density. The nuclear density, we'll call it rho n, is the mass of a proton over its volume. The mass of a proton is 1.67 times 10 to the minus 27 kg. Its volume is calculated above as 2.57 times 10 to the minus 45 cubic meters. And hence we get the density, the nuclear density, to be 6.5 times 10 to the 17. And this is in kg per cubic meter. So now we have the nuclear density of the proton. Now, let's calculate the atomic density for the entire hydrogen atom. So first we need to calculate the volume of the atom. The volume, again, we assume it's spherical, is 4/3 pi r cubed, where r is now the Bohr radius that we are given. That's 4/3 into pi, and r cubed is given by 0.53 times 10 to the minus 10. And this is all cubed. And this gives us a volume of 6.24 times 10 to the minus 31 cubic meters. So now we have the density of the hydrogen atom. We can calculate the atomic. Since we have the volume, we can calculate the atomic density. We'll call that rho A. So rho A is the mass over the volume. The mass, again, is contributed by the single proton, which has mass 1.67 times 10 to the minus 27 kg, over its volume, which we calculated to be 6.24 times 10 to the minus 31 cubic meters. And this gives us a density 2.68 times 10 to the 3 kg per cubic meter. And now we can calculate the ratio of these densities. So the ratio of the density, the nuclear density, to the atomic density, rho n over rho A, is equal to 2.4 times 10 to the 14.